Hey guys, we're going to do the next section, which is indirect proofs, and starting on page 317. This is a really short section, but it has a really big idea going along with it. So indirect proofs starts off with something called indirect reasoning. That's when all possibilities of something are considered, and then all but one of things are proved to be false. That means the remaining possibilities must be true. When we use this, we're going to go into, so proof using indirect reasoning is usually called indirect proof. Often you're going to have a statement and its negation, which is also its opposite, are the only possibilities. When you see that one of them will lead to a conclusion that contradicts something you know to be true, something that's in the given, you can eliminate that possibility. So since you're going from something that's a contradiction, an indirect reasoning proof or indirect proof is sometimes called a proof by contradiction. So how to write a indirect proof? You state the opposite, or you state the negation of what you want to prove. You show that this negation leads to a contradiction, and you conclude that the negation must be false and what you want to prove must be true. So with these, it's you're just kind of given, you have the given and then the prove. You take the prove, you take the opposite of the prove, and then you use that in order to show that it must be false. All right, so we're going to do a couple different examples with this. Okay. For these examples, suppose you want to write an indirect proof of the statement. And we're only going to look at the first step of it. So what would you assume? That should be would. What would you assume? So in the first one, an integer n is divisible by 5. So you have to think of the opposite of is divisible. So the opposite of is divisible is not divisible. So the opposite of is divisible by 5 is not divisible by 5. So you assume temporarily that n is not divisible by 5. Second one, you do not have soccer practice today. If you think of the opposite of this. So the opposite of this, of do not have, that's the statement going, is have. So the opposite of do not have is, do have. Assume temporarily that you do have soccer practice today. Alright, now I'm going to ask you guys to try these. Triangle BOX is not acute. So the opposite of this would be triangle BOX is acute. Next one. At least one pair of shoes you bought cost them more than $25. This one could be tricky a couple of different ways. At least one pair of shoes you bought cost more than $25 would be no pairs of shoes cost more than $25. Alright, now that we've gone through that, we're gonna give you guys some statements, and you're gonna show which ones are going to be contradictions. These kinds of questions that we're going to do next are some things you're going to see on ACT tests and SAT tests. Okay, so these are the kind of questions you would see on an ACT or SAT test. Which two statements contradict each other? We are given line FG is parallel to line KL. Line FG is congruent to KL, and line FG is perpendicular to KL. Which two cannot happen at the same time? We look at each one of these paired off individually. Paired off together, one at a time, sorry. So you look at, can a line be parallel and congruent? Yeah, parallel line can be parallel and congruent at the same time. Can a line be congruent and perpendicular? Yes, a line could be perpendicular and parallel. Perpendicular and congruent. And last one, can the line be parallel and perpendicular? No. Parallel means they never cross. Perpendicular means they're crossing at right angles. So 1 and 3 contradict each other. These are all what I just said, just written out before. So line can be parallel and congruent, so 1 and 2 are okay. A line be congruent and perpendicular, 2 and 3. A line cannot be parallel and perpendicular. Next one, a very common one you would see on a test again. Triangle XYZ is acute, triangle XYZ is scalene, and triangle XYZ is equiangular. Which two contradict each other? So, which two do you think? 1 and 2, 1 and 3, or 2 and 3? So if we do 1 and 2, it means acute, let all angles are less than 60, all angles are less than 90, and scalene, all sides are not the same. Yeah, that can happen. How about if it's acute, all angles are less than 60, all angles are less than 90, and equiangular, all are the same angle? Well, yes. If they're all less than, if it's equiangular, that means they're all 60, which means it's acute. Then 2 and 3, all angles are 60 degrees, and all sides are different lengths. Those two contradict each other because equiangular means that they're going to be all 60, which means all the sides are the same, which contradicts the scalene part. Alright, so now that we're going to go into one last problem where we are given a statement and a proof, and we have to use the contradiction of we have to state the contradiction and go through it and solve it by indirect proof. Okay, so we are given that 7 times the sum of x plus y is equal to 70, and x must not be equal to 4. We want to prove that x must not be equal to 6. So we start off by saying that y equals 6, plug it into the equation, and solve to find a contradiction. So we start off by saying 7 times x plus 6 equals 70, and then I'm going to divide both sides by 7 and get x plus 6 is equal to 10. And then I'm going to subtract both sides by 6 and get that x equals 4. But that contradicts what I said before in my given. So this x equals 4 contradicts our given of x does not equal 4. So our assumption of y equals 6 must be false. Therefore, y cannot be equal to 6. Must be true. Alright, so that's it. What we're going to do today. In class, we're going to do some group work and other examples trying to get this proof by contradiction or indirect proof easier.